Welcome back to the final installment on the topic of algebraic fractions. So without further delay, let's get started. If the pressure is 24 pounds per square inch, volume is 15 cubic feet, what will be the new volume if the pressure is increased to 30 pounds per square inch? Right away, we could tell that pressure and volume are in an inverse relationship. In other words, when pressure increases, volume decreases. So let's assume this imaginary equation y equals n over x, where n is some proportional constant. Okay, let's treat x is our pressure, which is x is pressure and y is volume. Okay, so first we have to figure out our proportionality constant. So when y is 15, that is when volume is 15, pressure was 24. So n would be 360. Okay. So what would be the new volume if the pressure had been increased to 30 pounds? That means y equals 360 over 30, which is 12 cubic feet. It's not easy. We will use the same logic for the second question. You're given a series of values for x and the corresponding values for y. If you're told y varies inversely with x, what's the value of n? So let's say y equals n over x. Please do not confuse this n with the n provided in the question because this is a proportionality constant. You can pick any two values. In other words, one set of x and y from a series of values given here. So let's just pick the first row. That means when x equals 4.8, so when x equals 5, y is 4.8. So 4.8 equals n over 5 implies n equals 24. So now we know our proportionality constant. We have to figure out the y value for n. So let's say y equals n, x equals 3. That means n equals n over 3, which implies n equals 24 over 3 equals 8. So 8 is the correct answer. All right. Again, you're going by the same logic, except this time is directly related. So y varies directly with square of x and cube of z. So first, let's write a logical expression. So y equals some proportionality constant times x squared times z cubed. Okay, y equals 24 when x is 1 and z is 2. So what this will give us is k value. So k would be 24 over 8, which is 3. Right? Now, what is y value when x equals 3, z equals 1? So that means y equals 3 times 3 squared times 1 cube. So that would be 27. Okay. So this particular problem, you can solve it in at least 2 different ways. Let's show you a way that may appear to most novices, and an expert may solve it differently. Okay, so how can we do that? So at the start, you have 3 flies, right? And it triples every week, right? Triple means you essentially are squaring that value. In other words, after the first week, okay, you'll have 9. That is 3 plus 3 plus 3. Okay, you're not doing 3 times 2. That's double. Okay, you may be tempted to think, okay, triple means it will be 3 times 2. Okay, that would be what people are thinking is when they think triple, they're thinking 3 plus 3. So that's 6. So no, it's 9, right? In other words, In other words, at the end of the first week, you have 9 flies, right? Right? Again, you multiplied 3 times 3 to get 9. So at the end of week 2, you'll multiply by 3 again, which would be 27 flies, right? Right? And again, at the end of week 3, it'll be 27 times 3 is 81 flies. And at the end of week 4, 243, right? So you would have 243 flies after 4-week period, right? So what other way we can do it would be, you can use a mathematical logic, which is I times R power n, and I corresponds to whatever fly you have at the start. You have 3, right? And R is the rate at which the flies are tripling, which is 3, and n corresponds to the duration, which is 4 weeks. So 3 power 4, that is same as 3 times 3 times 3 times 3 times 3 is 243 flies. So there's 2 world of thoughts for this problem. Depending on whatever strikes you at the time you take the test, you're welcome to use either of the methods. So I corresponds to the start, which is 3 flies. R corresponds to the rate. N corresponds to the duration or the time. Okay, R is the rate, that is, it triples every week. What this logical equation does is it takes away the guesswork. Am I multiplying by 2 to say that it's triple because it's 3, 3? Or should I multiply by 3? Or should I square or cube? All of these guesswork is taken away by the logical equation that you have. Okay. D and C are diameter and circumference respectively of the same circle. D equals 12 L squared, C equals T squared. Which of the following is a true statement? T varies directly with L, T varies indirectly with L, T varies indirectly with the 4th power of L, and so on. So first we have to figure out what is the circumference of a circle. Circumference of a circle is 2 pi r, right? We know circumference is T squared, so let's leave it as it is. Let's not change anything. So diameter is 12 L squared. So that means radius would be 12 L squared over 2, that is 6 L squared. So that will be same as 2 pi times 6 L squared, right? You're asked to determine T, right? So T would be square root of 2 pi 6 L squared, right? Right? Fourth power of L. Okay, let's keep it. You can do it 2 ways. As I said, I've taken square root of it, right? So T varies directly with L. T varies indirectly with L. T varies directly with the 4th power of L. T varies indirectly with 4th power of L, 4th root of L. What would be the correct answer? Well, all of these are constants, okay, in this expression. You do not even need to worry about that. You only have to focus on this, okay? If you leave T as a square, then whether it's you take the square or not, it's a direct relationship. So anything with indirectly is incorrect. So it'll leave you with just these 3 for answer choice. Directly with L, T varies directly with the 4th power of L. T varies directly with 4th root of L. Well, whether you leave it this way as a T squared or T, irrespective of it, say you take the square root. Well, there's no way that's fourth root of L, is it? Okay, in fact, if you have to think about it, it would be T equals L square root of 2 pi 6, or T equals L 12 pi. Why? Because if you take square root of a square, then it becomes just A. We apply that logic here. So we know T equals L, so it's directly related and it's also linear. It's not squared, it's not fourth root or any of that stuff. So all of these are incorrect, so which means T varies directly with L. Okay. X varies directly as A and inversely as Y. Z equals Y squared, B equals A. Okay. So if you notice, all the answer choice are in terms of Z, right? So X varies directly as A and inversely as Y, right? So how could we get everything in terms of Z? So we know X equals A and inversely as Y. This is what this is saying. Okay, X varies directly as A and inversely as Y. Okay, so what are the two other terms we have? We have Z equals Y squared and B equals root A, right? So because here A is, let's actually substitute, Y equals A over X, right? Why? Because Z equals Y squared, right? So that means Y squared would be A squared over X squared, right? So now let's go ahead and substitute. We now have Z equals Y squared, and we have something in terms of Y squared as well. But we notice that our A and B are not related yet. So we have to make that adjustment. So if you square once, it's B squared equals A. If you square again, it'll be B power 4 equals A. So let's go ahead and substitute Y squared equals B power 4 over X squared. Let's substitute this into Z equals Y squared. So Z equals B power 4 over X squared. This is our ultimate expression in terms of Z. So we know Z varies directly with B, inversely with X. Let's first get that out of the way. Z varies directly with X, that's incorrect. Z varies inversely, well, that's a likely possibility. Z varies directly as a square. Z is not directly related to X. So choices 1, 3, and 4 are incorrect. What's choice 2 and 5? Z varies inversely as the square of X and inversely as, well, it can be both inverse, so that's incorrect. Z varies inversely as the square of X and directly as a fourth power of B, and that's correct. Okay. The radius of a base of a cylinder is R. The height of the same cylinder is H. The cylinder has a volume of 100. So volume of a cylinder is pi R squared H. Okay. We know radius is, well, we have to get everything in terms of T. Okay, that's the key here. So you do not have to shuffle too much. So we know T equals square root of R. So R would be T squared, right? R squared would be T power 4. So we can substitute. And similarly, if you fourth power the volume, then we can get H, right? See, we've got this, right? Just like this, we have V equals square root of, fourth root of H, right? So if you take fourth power of the volume, that'll be H, right? So V equals pi times R squared would be T power 4 times H would be B power 4, right? In other words, t power 4 equals v divided by pi times this new power 4, right? So t varies directly with v, well, that's not correct. T varies directly with square root of v. Is it t varies directly with no? T varies indirectly with no. T varies indirectly with v is the correct, right? Because if you say take fourth power square root, okay? Okay. If you do that, then okay, this becomes t equals v power 4 over pi times just this. So t only varies indirectly with 1 over v. This seems tempting, but it's not, because it says t varies directly with square root of v. Well, I don't think it's even directly, so this would be correct as well. So t varies indirectly with v is the correct answer. Okay, if y varies inversely as x, y equals 14 when x equals 3, find y when x. We've done a problem like this before, so let's assume y equals n over x. So y equals 14, n over x is 3, so n is 14 times 3. That's 42, right? So what is y when x equals 28? So y equals 42 over 28. So we can do this as what? 2 times 21. This is 2 times 14. This is 7 times 3. This is 7 times 2. So y equals 3.5 is the answer. Okay. If x equals 2, y equals 18, and x equals 9, y equals 4, what's the value of y when x equals 12? Y varies inversely with x. We've done just a similar problem now. Y equals n over x. You can pick one set of value, okay? You don't have to use both. So let's pick this one. So y equals 9 when, y equals 4 when x equals 9. So n equals 36. So y equals 36 over x. So 36 over 12, y equals 3. Okay, we've done this problem before, so we must have accidentally got through the crack. So let's ignore it. Okay, I like this problem because, and this is the last problem in this installment and in this video. So let's go ahead and do it. So we have y equals x squared minus root 3 times x plus root 5x minus root 15 over x minus root 3. You have to know that when you write this, the x is not part of the root. It's only the root 3 is part of it. So keep that in mind. So y equals x squared minus root 3x plus root 5x minus root 15 over x minus root 3. Okay. If you think of this as just like a quadratic expression and you're trying to factor, then this will become y equals, if you take x out of the bracket, it's x minus root 3, plus if you take root 5 out of the bracket, then it becomes x minus root 3 as well, over x minus root 3. So if you combine terms, y equals x plus root 5 times x minus root 3 over x minus root 3. So these cancel out, gives you y equals x plus root 5, right? So how could we get rid of, how could we find the roots of, how do we find the root? That's what it's ultimately asking for. That means we have to assume y equals 0. That means x plus root 5 equals 0, x equals negative root 5. That's it. So you may be wondering, how do I know if I take root 5 out, I'm going to get root 3? Well, the way it works is when you multiply root 3 times root 5, you get root 15, right? So if you have root 5x minus root 15, that's same as root 5x minus root 5 times root 3. So that's why you can take root 5 out of the bracket, which leaves you with root 5 x minus root 3. So this is the logic that was used in making that simplification, and this is how you do this problem. So I think we've exhausted the concept of algebraic fractions at this point. So if you've learned something, consider subscribing to my channel. Thank you for watching, and I'll see you with another video.